Let's have the next one, determining the numerical coefficient for the term with the literal coefficient a to the power of 7 and b to the power of 15 for the expansion of the given expression here. We have the binomial expression 2a minus b, and it's expressed or raised to the power of 22. This gives us an n equal to 22. Now, how do we identify the numerical coefficient even without expanding it using the actual expansion, or even without the use of Pascal's triangle? Now, we just need to look into the binomial theorem, and it tells us this manner: for x plus y raised to the power of n, we can use here, this is the expansion, the summation of n taken r, x to the power of n minus r, y to the power of r, as r starts from 0 to n. Okay, so we simply need to take this portion here. We don't actually need to look for the summation, just this portion here, because we just need to look at the numerical coefficient of a singular term, the term where the result would be, or the literal coefficient is a to the power of 7, b to the power of 15. For us to be guided, take note that in our formula here, we're using x and y. That's why we have here x and y here. But for our given, our x is actually twice a, or 2a. And our our y is not just b, but negative b. Consider the sign before as, the operation before as its sign. Hence, that is why our y here will be substituted by negative b, and our x here will be substituted by 2a, which will give us this result. By the way, before we forget, if we expand this, we will actually expect n plus 1 terms, which will give us 22 plus 1, 23 terms. So it would take us a lot of time to find the actual expansion. So since the question is only the numerical coefficient, let's attack to that. So again, you will have here n taken r. But our n is already given as 22, but the r is still unknown. How do we identify the r? I would like to take you in comparing these two in this form here. This is our target. You would like to take the numerical coefficient of a to the power of 7 and b to the power of 15, and this should be expressed as x to the power of n minus r, y to the power of r. From this, we can get actually our r be equal to 15 already. Okay, that's automatic, the result here for our r. We already have our r, our n is already identified, so basically we will have that. At the same time, we will get here x to the power of n minus r and y to the power of r. As mentioned, we will not be using x nor y, but we will be using these representations for our given equation. Hence, this is what will happen here. N is 22, taken 15, or combination 15. X is actually 2a, not just a. Power of n minus r is actually, you have n minus r is actually given as 7, and y to the power, not y, negative b, our y raised to the power of 15. Okay, so we can see here that the numerical coefficient is not just the result for this, but it also includes 2 to the power of 7 as we apply the law of exponent. At the same time, we know that there is negative 1 here raised to the power of 15. Again, with the law of exponent. So moving down, we'll just use another color. So we'll get here 22 factorial, that's for our combination here, 15 factorial times 22 factorial, minus 15 factorial. Then 2 to the power of 7, a to the power of 7 using the laws of exponents, negative 1 raised to the power of 15, and b to the power of 15. Okay, so we'll have here 22 factorial over 15 factorial times 7 factorial. 2 to the power of 7, negative 1 raised to the power of 15, a to the power of 7, b to the power of 15. We don't actually need this to include in our answer because we just asked about the numerical coefficient, but we are writing here to be guided that this is our intended target, so that we will be guided that we are just following the process. So what is actually 22 factorial over the product of 15 factorial and 7 factorial, or also known as, again, 22 taken 15 or 22 combination 15? That is actually, please use your calculators there and try to verify if my answer is the same as yours, so that I will also be guided with whether my answer is correct or not. So if we have here 22, I'm using my calculator now, combination 15, we will get a result of 170,544 times 2 to the power of 7 is another value. Okay, so 2 to the power of 7 is equal to 128 times negative 1 raised to an odd exponent is just negative 1. Again, a to the power of 7, b to the power of 15. So this is actually equal to, when you multiply that, 170,544 times 128 times negative 1 will get us negative 21,829,632. That is the numerical coefficient of a to the power of 7, b to the power of 15. This is just what we were asked to solve for the expansion of, let me return, yes, we have here 2a minus b to the power of 22 for this specific term. So we were able to solve this using this process, and we are doing this clearly to make us realize that we are not just getting a to the power of 7 and b to the power of 15 here, since our terms are 2a and negative b respectively. So the x is 2a, so include the numerical coefficient raised to 7 together with minus b raised to the power of 15. Okay, so that will be the correct answer for this intended item. So this is how we look for numerical coefficients in the expansion for using binomial theorem, not necessarily expanding them thoroughly, just numerical coefficient paired with the intended literal coefficient. In the next few videos, we're going to talk about the multinomial theorem, which talks about the expansion of multinomials. In short, we will have more than 2 terms raised to an n exponent. Thank you very much for watching.